Welcome back to 4.2. This is a relatively short and, dare I say, pretty easy section. I've always found that multiplying fractions is actually pretty easy, even easier than adding fractions sometimes. So, side tangent real quick, you probably have seen something like 1/5 plus 3/5, and this is actually pretty easy. If you have a fifth and you add 3 more fifths, then you would have 4/5. And that's not too bad. That's pretty easy. But what happens if you have to do 1/5 plus something like 2/3 without common denominators? That's a little bit more tricky. At least it can get pretty tricky. So, and you might not have learned how to do that yet, but multiplying fractions is actually a little bit easier than that. So, if you didn't already know this is something that I didn't realize until I was older, that using the word of, is the same thing as multiplying fractions. So if you said, what is 2/3 of 12? That's the same thing as saying 2/3 times 12. Or what is half of 100? That's just the same thing as saying half times 100. And in chapter 1, we learned a couple of rules. When we were talking about division and also talking about reciprocals, we learned these 2 rules here. That a lot of times we saw this the other way around here. But if we have an integer times a reciprocal, then we would just get that integer over the reciprocal, a over b. So a times 1 over b is equal to a over b. And we'll be using that one a lot. And then the product of a reciprocal, or reciprocal of a product, it would be the other way around. If we have 1 over a times 1 over b, then we just multiply what's in the denominator. So we're going to use those for the next couple of problems. So, for example, this one here, we have 2 times 1/3. Well, which rule can we use? We can use this rule right here. And a number times a reciprocal, you just put this on top, right? So 2 times 1/3 would just equal 2/3. It would just be, again, a over b would be a times 1 over b. All right, so then the next one, we compute 3 times 4 over 5. Okay, so we haven't done something like this yet. Using our definition of division to write 4/5 as the product of an integer and the reciprocal of an integer. Okay, so we know that 4/5 is going to be the same as 1/5 times 4. Or we can swap the order because it might look more familiar to you if you say 4 times 1/5. And again, we have this product of a reciprocal here. So if we do 4 times 1/5, we would end up getting 4/5, which is what we started with, right? So we know we can write it like this, and that works. All right, so then B, use the appropriate properties of multiplication and your result from part A to compute 3 times 4/5. All right, so we already broke down 4/5 to be the same as 4 times 1 over 5th. So now all we need to do is swap that out. So let's do 3 times, our new 4 over 5 is going to be 4 times 1 over 5. Okay, and you know that multiplication is commutative. We could change the order, but I think it's probably easiest if we just go left to right. We can do 3 times 4 is 12. Now we have 12 times 1/5. And what do we do when we have a number times a reciprocal? We just put that number on top. So that's going to be equal to 12 over 5. And that's going to be our answer. All right, so in this problem, we compute all this stuff times 7 over 6. Okay, well, so first of all, A, explain why 66,666 times 7 over 6 equals a bunch of 6's over 6 times 7. So why do you think that that's the case? Well, we know that we typically will go back to our rules here. Right here, this A here goes to the numerator of the fraction, right? All right, so that's what we'll do here. So we'll bring the 66,666 to the top here. So we'll do 66666 times 7 all over 6. So we could multiply this out, but that'd be a pain to do this big number times 7. But we also know that no, 5 of them over 6 times 7 also works, because this is the same thing, just in reverse, right? Because we had something like a times 1 over b. And actually, let's write this differently. Let's do, oh no, I guess I can't undo if I leave the slide. Okay, well, let's say this is c, okay? And so then that's going to become a times c over b. But we also know that this is the same thing as c times a over b, right? Because in order to combine this, we would just multiply this with the numerator. So it would end up being, once again, c times a, or a times c, however you want to write that, over b, which is the same thing as this here. Same thing. So we just kind of broke it down in a different way. We had a to the outside to begin with, then we went and combined them, and then we just took one of them out. Does it matter which one we take out? We can do either one. So instead of taking a back out again, we took c out again, and then we got this. So it's the same thing that we did here. So we basically, we plopped the 6's on top, and then we took out the 7. All in all, it's the same thing. Using the same rule, just different part of the number to swap it out. So it is true that you could say a times b over c. You can combine that to say a times b over c, and that's also equal to a over c times b, which is what we just did. Okay, so now that we've gotten that, well, now we can easily compute this, because 66,666 divided by 6 is going to be 1 times 7. And that's going to be 7, 7, 7, 7, 7. And that's much easier than trying to multiply this. No need to do that. Okay, so we have another rule for this. If you remember from a few slides ago, back to our rules, we have this rule right here. So 1 over a times 1 over b equals 1 over the product of a and b. All right, so we know this is going to be equal to 1 over 3 times 2, which will be 1 over 6. Easy enough, we're flying through these. Okay, so in this problem we compute 2/3 times 4/5. So this is where we're going to come up with a new rule that's going to make multiplying fractions pretty easy going forward. So use the definition of division to write each of 2/3 and 4/5 as the product of an integer and the reciprocal of an integer. Okay, so what that means is we convert this 2/3 to be a product of a reciprocal and an integer. So that's going to be 2 times 1/3. So that's the reversal of that rule, right? Because we know if we do, if we want to combine them again, we do 2 times 1 over 3, or 2 over 3. We get back to what we started with. All right, so we did it for 2/3. How about 4/5? Same thing, 4 times 1/5. Okay, so now we can multiply these two together. So 2/3 is the same thing as 2 times 1/3 times, well, 4/5 is the same as 4 times 1/5. And we can use the commutative property and move some things around. So let's do 2 times 4 times 1/3 times 1/5. Well, 2 times 4 is just 8. And we know if we have product of reciprocals, that's going to be 1 over 3 times 5. That's going to be 6 times 1 over 15. And now we know this rule already. Just put the 6 on top, and it's 6 over 15. Okay, and that's our answer. But look what we did. That's not right. I messed something up here, didn't I? Where did I get 6 from? 2 times 4 is not 6, it is 8. All right, 8 times 1 over 3 times 5, and 8 times 1 over 15, and 8 over 15. All right, that looks better. Okay. So if we go back to our original problem here, if you notice what we did, so we have 8 in the numerator, right? We had 2 and 4 in the numerator. So all we did was 2 times 4, right? 2 times 4 is 8. Our denominator, we have 15. All we did was 3 times 5. So our denominator, we have 15. So all we need to do, if we have 2 fractions, a over b times c over d, we just multiply across a times c in the numerator and b times d in the denominator, assuming that neither b or d are 0. But multiplying fractions is as easy as that. It's just, you just multiply straight across and then you get your answer. Sometimes you need to simplify, but all in all, it's just as easy as that. So I did break it down and show you why it works. Knowing the rules that we've already proved in previous chapters in chapter 1, all we had to do was just use those rules, move things around a little bit, and we got to the same answer. But ultimately, it just showed us that all we really need to do is just multiply across in these fractions. All right, so now knowing that, we can use that rule going forward to make these problems a little bit easier. So 4.13, we have these 2 fractions. It's going to end up becoming 35 times 48 over 6 times 7. All right, well, so we could just multiply this out and we would get the right answer, but, well, let's see if we can come up with a trick first. Let's actually swap the order of these 2, because we can do that. It's commutative, right? So let's say 48 times 35 in the numerator, and the denominator, let's keep it 6 times 7. Well, so we said if we wanted to combine these, we can. We just multiply the top and multiply the bottom, and we're good. Actually, what if we want to break them apart? Can we do that? So this is just multiplying. Can we just split it up and say 48 over 6 times 35 over 7? And yes, we can do that. So this might actually be a good idea, right? Because 48 divided by 6 is just 8. And 35 divided by 7 is 5. So now we have 40. So that's a little bit easier than trying to multiply 35 times 48 and divide by 42. This is a simpler way to do this. So just know that you can do this. You can re-split up fractions if you need to, and you can use commutative properties. So look for tricks like this to make things easier for you when you can simplify fractions like this. Okay, so what is 2/3 of 90? Remember that the word of means multiplication, so this is the same thing as saying 2/3 times 90. And we know with our rules, we could split this up and say 2/3 is the same thing as 2 times 1/3 times 90. And then if we multiply our integers here, then we would get 180 times 1/3. 1/3, and that would be 180 over 3. And 180 divided by 3 would be 60. Okay, another way we could have done that is instead of breaking it apart like this, 2 times 1/3, we could have just directly multiplied 90 times 2 to get 180 over 3 without these 2 steps. We could have skipped these 2 steps there. All right, so next one right here. What is 3/4 of 11/8? Well, we know of means multiplication, so 3/4 times 11/8. And all we need to do is just multiply across. 3 times 11 is 33. And 4 times 8 would be 32. And that would be our answer. Oh, and again, there's a video right here. Go check that out. All right, 4.15. Maya starts with 160 pennies. She gives 3/5 of her pennies to her brother Mitch. Mitch then gives 3/4 of the pennies he receives to his mother. How many pennies does Mitch give to her? All right, so let's take this one step at a time. Maya starts with 160 pennies. and she gives 3/5 of her pennies to her brother Mitch. All right, let's start with that. So 3/5 of her pennies. And how many pennies did she have? 160. So what is 3/5 of 160? Well, that'd be 3/5 times 160. Okay, well, couple different ways we could do this. Let's just go ahead and say it's going to be the same thing as 3 times 160 over 5. 160 times 3 would be 480 divided by 5. And that's going to equal 96 if we did that math. Okay, so what does 96 mean? We go back to our word problem again, and where were we at? Okay, Maya started with 160 pennies. She gave 3/5 of her pennies to her brother Mitch. Right, that's where we were at. So we got 3/5 of 160, and that was 96. So we gave 96 to Mitch. Got it, okay. So Mitch has 96. Now what? Mitch then gives 3/4 of her pennies he receives to his mother. How many pennies does Mitch give to his mother? Okay, so 3/4 of this 96 he gives to his mother. So now we have to do 96 times 3/4. Okay, well 96 times 3 would be, well, actually, you know what? Let's see if we can come up with a trick here. So yeah, so let's do 96 times 3 over 4. But instead of calculating this out, let's go ahead and pull out this 3. So now we have 3 times 96 over 4. So if we know that 100 is a multiple of 4, we talked about this in somewhere in chapter 3. I forget the section. Maybe it was divisibility test. That's what it was. Talked about divisibility test. We know that 4 is all multiples of 100 are multiples of 4. So if 100 is a multiple of 4, then 96 would also be a multiple of 4. So 96 divided by 4, if we did that real quick, 96 divided by 4 can go in 20 times to be 80, 16, and 4 more. So there'd be 24. So we have 3 times 24. And that would be 60 plus 12 would be 72. All right, a little bit easier than doing 96 times 3 and then doing that divided by 4. Again, look out to see if you can find simpler ways of solving these. Sometimes you can't, and sometimes you kind of just have to go through it. And it would have been fine if you didn't do it that way. If you did 96 times 3, 96 times 3 would be 18, and 270. That would give you 288. And then that would be divided by 4, so 288 divided by 4. 4 can go into 28 7 times. Let's do 70. Is that right? Yeah, 280. And then that leaves us with 8. And then there are 2 more. And that would give us 72. So same answer. Totally fine if you did it that way. But sometimes there's some shortcuts here. So anyways, that was the last problem. Go ahead and do your 4.2 exercises, and we'll see you for the next section, which is dividing by a fraction.